So we've learned about units and English and metric units. We've seen that the English system is used in the United States while the metric system is used in the rest of the world. And we saw that the SI, or the international system for naming, the scientific method for naming, is really based on the metric system. But chances are in chemistry we have to do a lot of unit conversions, whether it's from English to metric units or metric to metric conversions. And we do this by following a process called dimensional analysis that we will apply later also when we learn chemical equations. So how would we convert 7.8 kilometers to miles using dimensional analysis? Well, we always start with what we're given, which is 7.8 kilometers. Then we multiply it by a conversion factor. And we usually look this up. We can tell that from kilometers to miles, we're going from metric to English. So you use a table. In your book, it's table 2.3. And you find that 1 kilometer is equal to 0.6214 miles. This can be written as a ratio in which it says for every 1 kilometer, there's 0.6214 miles. Or it could be said that there is 0.6214 miles for every 1 kilometer. They both mean the same exact thing. So here, going back to dimensional analysis, when we have our kilometer unit on top, our given unit, don't forget this is written like that, then we automatically put our unit on the bottom, our given unit. And the desired unit, which is miles, is placed on the top. Now, we simply write our conversion. We say for every 1 kilometer, there is 0.6214 miles. Now you see the kilometers cancel out because one is in the numerator and one is in the denominator, and then we simply plug this into our calculator and we get a number that is 4.8469 miles. But remember that we've learned significant figures, and we are only as good as our weakest link. And so our measurement here has 2 significant figures. So we're limited by 2 significant figures. So we round our final answer to 4.8 miles and report it like so. Okay, now let us do B, where we convert 0.825 meters to millimeters. This is a conversion from metric to metric. Again, in dimensional analysis, we always write what we are given times a conversion factor. And here, since meters is on the top, we're going to put meters on the bottom, and our desired unit of millimeters is going to go on the top. Okay? Let me fix that a little crooked. So our meters are going to go on the bottom and our millimeters on the top. Now, what is the conversion factor? In the previous example, we looked it up in a table. You can also look this in a table, but I expect you to memorize that. I expect you to memorize all the prefixes for metric multipliers. So, a good way to remember this is to remember that meters is our base unit. And then we have decimeters, and we have centimeters, and then we have millimeters, right? So which is bigger? The first question you want to ask yourself, which unit is bigger, the meter or the millimeter? Well, the meter is going to be bigger because it's further up on the top. So the meter is automatically going to get a number 1. Now, how much bigger is the meter? Remember that these units are all related by a power of 10. So since we moved 1, 2, 3, that's 3 tens, we can also write that as 10 to the third. Because remember, 10 times 10 times 10 is the same as saying 10 to the third. So then we simply plug in 10 to the third. We don't have to worry about negative exponents because we've already signed the bigger unit with 1. And then again, you see that the meters cancel out and we're left with our desired unit of millimeters. And another great thing about metric to metric conversions is that we don't really even need a calculator for this. This is like saying 0.825 times 10 to the third, which is scientific notation. So if I wanted to go ahead and carry this out, I can either keep it in this form or I can just go 1, 2, 3, and then my answer is 825 millimeters. So you see, I can easily go back from meters to millimeters or from meters to centimeters in my head because everything is related by a unit of 10. Okay, now I want you to give it a try and then replay this video to see if you got the same answers. For the first one, we want to convert 56.0 centimeters to inches. The first thing that we notice, this is a metric to English conversion. So that means we have to use a table. And I'll usually give you the table on the test. And we find that our conversion factor, we have a direct conversion in our table saying that 1 inch is equal to 2.54 centimeters, correct? So then in dimensional analysis, we always start with what we're given. So we write 56.0 centimeters multiplied by our conversion factor. Well, since centimeters is on the top here, centimeters is going to go on the bottom, and our desired unit of inches is going to go on the top. Now, what is the conversion factor? Well, this is saying for every 1 inch, there's 2.54 centimeters. So we can write it like that. So 1 inch is equal to 2.54 centimeters. Notice the centimeters cancel out and we're left with our desired unit of inches. And we go ahead and we plug this into our calculator and we end up with a value of 22.0472. But of course, we're limited by 3 significant figures here. So we must stop here in reporting our value. So our answer becomes 22.0 inches. Don't forget to put your number and your units. Your units are very, very important. Okay, let us go ahead and do the second example, where we are going from metric to metric. So that means we should have that memorized because we're using prefixes. So we want to convert, we always start with our given value and we multiply it by a conversion factor. Since meters is on the top, meters is going to go on the bottom, and our desired unit of kilometers is going to go on the top. Now let us see how these units relate. So remember, your meter is your base unit, but this time we're going up. So we have deca, then we have hecto, and then we have kilo. So which unit is bigger, the kilo or the meter, the base unit? Of course, it's going to be the kilo because it's further on top. So the bigger unit will automatically get a 1. Now let us see what factor difference is there between our base unit and our desired unit. And remember, these are all related by a factor of 10. So 10, 10, 10. So again, we find that from our meter, base unit to kilometer, is 10 to the third. And so this time we write 10 to the third on the bottom. And again, we just don't have to worry about negative exponents. As long as you assign the bigger unit with 1, then you can go ahead and have your positive exponents. Because at the end of the day, this is saying that because remember, the reciprocal of an exponent is 10 to the negative third, or it's saying that. So we go ahead and we do this in our calculator. The great thing about this is the meters cancel out and we're left with our kilometers. And so we find we actually don't have to plug this in again. You can just figure it out in your head, and you can move the decimal place 1, 2, 3 places to the left since it's a negative exponent, or the exponent is in the denominator. So it becomes 5.78 kilometers.